This is the review for Earth Science for chapters 2 and 3 in Unit 1. This is Earthquakes and Volcanoes. Alright, the first thing we're going to do is talk about earthquakes, and for this I'm going to just call them EQs, as you know. And so earthquakes happen at plate boundaries. Remember that these earthquakes are going to happen where the tectonic plates are moving, whether that be they're moving apart, they're moving together, or they're moving against each other, which of course, as you already know, are divergent, convergent, and transform, not necessarily in the same order. And where those plate boundaries meet, this is where you're going to find a fault. A fault is a fracture in the lithosphere, which is going to cause the blocks of rock to move past each other. And these are going to depend upon the type of stress they are under. The first one of these that we want to talk about is a normal fault. Now, a normal fault is where the plates are moving away from each other. So this one's moving in this direction, and this one over here is moving in this direction. And these faults are going to go up and down. You're going to get this sort of a movement. Again, this occurs at plates that are moving apart from each other or away from each other. And so this is, don't forget that key word, a divergent boundary. The next one is the reverse fault. And obviously it's called a reverse fault because it's actually the opposite of a normal fault. In this case, you're going to get boundaries that look like this, but this time this guy is going to be up on top. And these ones are happening actually at convergent boundaries. And in this case, this block is heading that way and this one is heading down. And again, they are moving together, meaning they happen at a convergent boundary. And the last type is a strike slip fault. And these happen at transform boundaries. And this one, they are going to move past each other, heading in opposite directions. Make sure that you understand what exactly an earthquake is. And so an earthquake is a shaking of the ground caused by the sudden movement of those large blocks of rock along a fault. And remember that the strength of the earthquake is going to depend on how much stress builds up before they move and the distance that they move. In an earthquake, we understand that there are different types of waves that occur with the earthquake. And so make sure that you understand that those are called seismic waves. And again, those are the vibrations caused by an earthquake. And that there are two main points of where an earthquake occurs, and those are the focus and the epicenter. Now, the focus is the part underground, and the epicenter is the part up on the surface. Next, you need to make sure that you know the different types of the seismic waves. So the very first one is the P waves. Again, those are known as primary waves. Right? They are the first to arrive. They are the fastest. Those are the ones that move in that push-pull. So if you push the slinky together and then they pull back together, it's not really a wave so much as a motion. And the other thing to remember about these is that they go through solids, liquids, and gases. Remember that the second type is S waves, which are the secondary waves because they arrive second. They are about half the speed of a primary wave. And these are the ones that wave either up and down or even side to side. Remember, they travel through only solids. They do not like liquids or gases, and they stay away from them, so they only go through solids. These waves are actually how we realize that the interior of our Earth, that there is a liquid outer core, is because we realize these waves will not go through that outer core. And the last one are surface waves. And the surface waves are the most dangerous. They're the most damaging, but they are the type that only occur on the surface, and they are last. Earthquakes are measured using a tool called a seismograph. Obviously, size from seismic. So these are a seismograph. And they measure those seismic waves. And they do that with that pen tool that at the littlest bit of shaking, it's going to draw the lines, which causes the data to be taken. The last thing we're going to talk about is measuring earthquakes and the amount of damage that they cause and how we can keep that from happening. So measuring an earthquake, remember we used to use something called a Richter scale, but we actually now use something called a moment magnitude scale. Okay, and this moment magnitude scale, it's based on the total amount of energy released by an earthquake. If I'm looking at an earthquake that is a 0 to a 4, it's going to be pretty minor, all the way up to an 8.0 and above, which is going to be a major or total destruction. Remember, the moment magnitude scale, it's more accurate because it measures the damage that is caused. Know the different levels of the magnitudes for the moment magnitude scale and how they relate to each other. You don't have to necessarily remember the exact numbers for each type, but do be able to signify the difference between, say, a 2.5 earthquake and a 7.5 earthquake. Damage from an earthquake, so earthquake damage. Now, this does not typically happen from the earthquake itself. It's from all the things that happen because of the earthquake. So you've got moving blocks of rock, you've got buildings that have been damaged, you've got fires, landslides. Remember a couple of new vocab words such as soil liquefaction, which is that process where the shaking ground causes loose, wet soil to act like a liquid, and a tsunami. So remember what a tsunami is. We saw lots of video of those and the extreme damage that they can cause. Know how they work and that it's a water wave caused by the earthquake. All right, the first thing that we're going to talk about when it comes to volcanoes are mountains. And in that, we are going to talk about first where most of those mountains happen. And those are along tectonic plate boundaries. And those are going to be when the plates are moving towards each other. This is in a convergent boundary. They are moving towards each other. Okay, know the difference between a folded mountain and a fault block mountain. In this case, we're going to talk about a folded mountain. So these are where our plates are moving towards each other, and this is either where an oceanic plate sinks underneath in the form of subduction, or when a continent to continent are actually going towards each other. So when these happen, they start to create a fold in the land, and this causes the folded mountains to occur. A fault block mountain, okay, so these are ones that are going to happen where the plates are actually moving away from each other. So these are at divergent plates. So as the lithosphere is stretched, we're going to have a piece of land that is cut into slices as it goes. Okay, and as this happens, you're going to find that these these pieces out here are going to start to tilt. Okay, and then this center section is going to drop, and again you're going to get tilting rock out here, which is going to cause mountains to form with a valley in between. So to summarize the difference between folded and fault block mountains, remember folded mountains are pushed up by a slow continual stress that causes the rock to gradually bend, while fault block mountains form from earthquake by earthquake as stress builds up along the crust and it releases the movement of the rock. Folded mountains form where continental crust is being compressed. Fault block mountains form from where it is being stretched. Remember, again, fault block mountains happen where the land is being stretched apart. Okay, the next step is in a volcano. Remember, first off, what a volcano is, that it's an opening in the crust through which molten rock fragments, and hot gases erupt, and a mountain is built up from the erupted volcano, or from the erupted materials. Remember how a volcano is shaped, a typical volcano. Remember that down here is the magma chamber, that up through here is the magma pipe, and then up here would be the crater. Flowing down after an eruption would be the lava. Remember the difference between lava and magma. Lava is outside of the earth. Magma is on the inside of earth. Okay, next up, remember again for that magma, magma is on the inside of the earth, lava is on the outside. However, the main thing to remember is how silica plays a part in the magma, that a high magma or silica amount will cause a violent eruption because it is a more solid, kind of thick magma, and it traps the gases. A low amount of silica is going to cause that gentle eruption, and again, that's because it's loose, it's a little more flowing, and it allows the gases to escape. The things that come out of a volcano include rock fragments and gases, and even the most deadliest part of a volcano, the part that is the most dangerous, and that is the pyroclastic flow. And that, again, is the definition is the volcanic gases that are mixed with rock fragments, and this all stays near the ground, and it's going to cause a really deadly, really hot mixture that can cause a lot of damage. The size and shape of the volcanoes can vary. There are 3 different kinds. There is a shield volcano, and these are the ones that build up over time, layer by layer, until you get a gradual forming of the volcano. An example of this volcano are the Hawaiian Islands, because as it builds up, it builds that land for the islands to be on. These are going to kind of create, again, kind of a dome-like shape. The cinder cone is another type, and then the last type is a composite volcano. Composite volcanoes are ones like the Mount St. Helens. These are what you typically think of when you think of a volcano. All right, the last section that we want to talk about is the effect a volcano can have on our world. And the first one of those is how it affects land. Those has those negative effects such as lava flows, volcanic ash, landslides, mud flows, pyroclastic flows that I talked about a few minutes ago, and steam explosions. Those are all dangerous parts of the volcano. Remember that it can do good things because it can actually create land, and it can give us a really rich soil as well. Next up is what an eruption can do to the air. So first off, there's nasty smelling gases that can come out of a volcano, and they can also be very deadly and very dangerous. And when those gases mix with, the water in our air, it actually can cause acid rain. The other thing that can happen with the air is we can get weather changes. And remember, those can actually occur throughout the entire world from a volcano that happens anywhere. Those weather changes include when the ash is lifted into the air and the wind carries away. What happens is the sunlight is unable to get to the earth. And remember, that can actually lower or decrease Earth's temperature. The last section is how it affects water. And I just want you to remember the various types of water. So there are hot springs. And that is where the magma has heated the water, and it creates that calm little pool. People like to swim in these. There are geysers, and these are those things that we see typically like Old Faithful at Yellowstone, where the water shoots into the air because it's gathered in an underground area and it becomes pressurized and it shoots it out. There are fumaroles, Fumaroles, and these are similar to a hot spring, but instead of liquid water, they release steam and other gases. And then our last item is a deep sea vent. You guys just watched a movie on what kind of things you can see down there and what they are. And remember, these are also hypothermal vents, and these are hot springs that are formed at spreading centers, which again are at a divergent plate. Remember how a deep sea vent occurs. Remember how they work and what happens down there. Specifically, this is where the cracks form in the ocean floor, where cold salt water or seawater sinks to the depths, and then that seawater is heated by the hot rock and magma and rises again. And that hot water coming out of the ocean floor is, remember, it's got those rich dissolved minerals and gases, and that's what creates those interesting creatures and such that we see down there as well. All right, that's the end. You should be fully prepared. Hopefully, I haven't given you too much information. Remember, this is a pretty involved test because we actually took 2 chapters and condensed it into one test. So we've got earthquakes and volcanoes. So I just want you to remember to study hard. Don't forget your note card. And good luck, and we'll see you for the test.